Ready?
Yeah.
Hi, Gianni. Sorry you're not feeling well today. And here we go with, we are talking about one loose end that we're tying up. Does that show up over here?
Yes.
There was a question on number 35 on the greeny sheet. And I just gave those back so you could talk with me about it. And the question came up right before the test. And I believe I had a 1/4 and you didn't. And I did it again, and then I checked the answer key, and the 1/4 was there, so I just want to tie up the loose end. So this is an integral problem, is that right? Number 35, Jonathan, is it an integral?
Yes.
Okay, but look, I reminded us what the derivative is, because in the middle of this, we have to find the derivative. Because looking at this, doesn't this arctan, it looks like this expression might be the derivative of that, doesn't it? So did that lead you to pick the u being arctan of x over 2? Did you get that far on number 35? All right, so that was a good start. So if you said that is the arctan, then Aaron, would you look on your 35 and tell me what you said the du was?
Yeah, I got 2 over x squared plus, 2 squared times 1/2.
All right, 2 squared. I'm sorry, times 1/2. That's where we differ. Because when you're using this rule to find the derivative of the arctan, remember,
Oh.
You okay?
that's a first. Does it go back on easily?
Yeah, it should. Just
Oh, there you go.
there you go. You okay?
Oh, got that on tape.
Talk about phones.
stand
I knocked it down a few times trying to put it.
Johnny, stand by. It's okay.
I'm so excited about this du. All right. All right. The
Mr. Cockham says hello.
The du follows this pattern, does it not? And this is, in this pattern, this is the u. Remember, oh, this is wrong. It's u over a, remember? And that is the a. So, Aaron, why? If that, remember how that is, u over a, u over a. So this is u. So actually this is a u within a u, is it not? Because this was our original u. And now we're looking at this step. This is our u on this step. So what's the derivative of that?
1/2.
No, u. This is the only u.
Oh,
because-
just the x.
Yeah.
That must have been what I did there.
Yeah, I think that's what everyone
It's just
did.
1.
Yes. Yes.
Oh,
All
okay.
right.
So then you get that extra 2, and then it,
Right.
it comes
All
out.
right, so I'll just finish it real quick, and you
Okay.
can change it on your greenie so that you'll sleep
Greenie.
peacefully tonight. Gianni, I know it's going to be rough for you. You don't have your greenie here to change. But now I'm going to go ahead and take the integral, and the integral, well, let me write this out. So we have the integral of the arctan of x over 2, that's my u. And the du is 2. Oh yeah, because there's a 2 there, Brendan, what do I have to do? I can't just stick a 2 into the problem.
You have to pull out a 1/2.
Right. So then when I actually do this integral, I follow the formula and I pull the 1/2 down, and that formula has, well, this is the integral of u du now. So over to you, Morgan. What is the integral of u?
It is 1/2 u squared.
Right, and there's already a 1/2 there.
So 1/4 u squared.
Right, so then I get 1/4 u squared, which is arctan of x over 2 plus c, and I went into my other board. So for your sake, Gianni, this says 1/4 arctan x over 2 plus c. So that's
Is
why
it
the 1/4.
squared?
Pardon?
Is it
Oh
squared?
yeah, you're right, because it's u squared. Thank you. All right.
Yay.
All right. I just wanted to tie up that loose end before I would go on. Just a little problem. I think you were thinking that this was the whole U in that second step, and it wasn't. All right. So let's, whose test do I not have? Yours? Okay. I'll take your greenies back so I can give you credit for them when I grade these.
Oh yeah.
And I just gave them for you so you could look at that problem.
I need to staple mine back together again.
Alright.
Because I kind of tore them apart.
I fell apart. Okay.
Wait a minute. Is my name on there?
Is it? Why it's
I'm getting great. I'm getting some great footage here.
No name.
Like John's line.
Alright, let him alone, Brendan.
It was just during this break
Alright,
here.
did you start timing this?
Oh.
say we've done 5 minutes.
All right.
I might watch the video back just to see that phone drop.
Did it show up?
It was on that, and so you saw it perfectly.
Oh, that's such a sweet sound. That might be the last one.
Oh.
But we have it on tape. We can.
Listen back.
Replay that 2 seconds in.
Okay. Back to unit hyperbola land. So we had the hyperbolic trig functions. Would you find where are we taking notes?
Yes.
And I have we already did the derivatives and we did the integrals, but we haven't done any problems. So we will correct that in justice in a minute. But I left a lot of blanks here. So we're going to come up and fill in the blanks. So find your notes, and if you would all do them in the same color, how about orange? For example, I'll show you, you have to fill in 2 blanks apiece, and then if there's any left, we'll do them together.
Watch, Gianni. I'm not messing.
So this one, I remembered, is the derivative of hyperbolic sine is hyperbolic cosine, and that works in reverse over here. So the integral of hyperbolic cosine is hyperbolic sine.
Thank you.
So when you come up, would you do 1 in derivative land, that's here, and 1 in integral land? All right, so Aaron, Brendan, everybody just up and try to use orange.
Record this still.
I guess not. What's that for?
All right, Gianni. We'll see you later.